Okay, so for the second part of the review, we're on number 18. Find the missing side. So anytime you have one of these triangles with some given information and some marked information, just evaluate what you have, what you can tell, what you know. All right, I see that this side is 11. I see that this angle has one line, and this angle has one line, so that means these two angles are the same. And if I have base angles congruent, which is what these are because two of them are congruent, that makes these the base angles, and that means the sides opposite of those angles are also congruent. So this side is going to be congruent to this side. That's what that tells me. So that tells me that x equals 11. So there wasn't really a lot to that as long as you can recognize characteristics of an isosceles triangle. If the two angles are the same, then two sides are the same. And that's the same with equilateral. If three angles are the same, then three sides are the same. Okay, and on number 19, the same thing. So I have an angle and an angle. Two angles are the same. So that means the sides across from those angles are also the same. Across from this angle is 10. Across from this angle is 2x minus 6. And if they're the same, in math, the way we say the same is equal. So 10 equals 2x minus 6. And then I can solve for x. So I'm going to add 6. So 16 equals 2x. And last, divide by 2. So 8 equals x. And that is what it said. Okay, on number 20, it says to solve for x if the measure of angle 2 equals 2x plus 40. Okay, so I know that the measure of angle 2 is 2x plus 40, and that's right here. So that is 2x plus 40. And see, what else do I know by looking at the picture?
No, wrong class.
I see that three sides are the same.
Yeah.
This side's the same as this side, so it's equilateral if all the sides are the same. And if all the sides are the same, then all the angles are the same. So it's equiangular. And equiangular triangles means that they are all 60 degrees. 180 divided by 3 is 60. And if this one is 2x plus 40 and it's 60, then I can say that 60 equals 2x plus 40. Because that angle is both 2x plus 40 and it's 60. And then I can solve for x by subtracting 40. $20 equals 2x. And then I can divide by 2 to find out that 10 equals x. So anytime you get a problem, if you don't already have a diagram, then you should sketch one and label what is given. If you have a diagram, then kind of go over and remark everything so it kind of registers in your mind what you have. All right, so number 21. If triangle ABC is equiangular, equiangular is an important word, find segment AB. And then there's a hint. Find y first. Well, you have to find y before you can solve for the side length. If it's equiangular, it means all angles are the same. And I just said a minute ago, if two angles are the same, then two sides are the same. If three angles are the same, then three sides are the same. All equiangular are equilateral, and all equilateral are equiangular. So all three of these sides are the same. So if I need to find y first, then I can say the two sides that have information, 3y equals y plus 12. So even though I am solving for AB, I'm solving for AB, and AB is this side over here, there's no information on that side other than it's the same as the other two sides. So I have to work with what I'm given, is that the information on these two sides, and I know they're equal because it's equiangular. Okay, so first I'm going to subtract the y. So 2y equals 12. And then I can divide by 2. So y equals 6. Now I have y equals 6, but that's not my answer because I was asked to find AB, not y. Alright, so after I have that y is 6, I can plug it into either side. It doesn't matter which one I plug it into. I'll plug it in right here. So if this is 6 plus 12, then that's 18. So side AC is 18. So that means that side AB is 18. And side BC is 18. Because they're all the same. So to answer the question, segment AB equals 18. Okay, number 22. Find the length of segment AB. All right, so that's what I'm looking for. The length of AB. That's this one right here. Okay, if triangle ABC is isosceles, which I can see that because two sides are marked, and then it tells me that AB is 4x minus 5, so I'm going to write that in my picture. And then it tells me that BC is 3x plus 10. And it tells me that AC is 7x minus 5. Alright, so if I'm trying to find the length of AB, I don't even need the 7x minus 5 down here. It's really not going to come to play at all. Because all I need is that the two sides that are equal, AB and CB, I can say that since they're equal, then 4x minus 5 equals 3x plus 10. And then after I solve for x, I can plug it back in to see what the side length is. So I have 4x, I have 3x, so I'm going to subtract the 3x. So then x minus 5 equals 10. And then I can add 5. So x is by itself. And x equals 15. Just like the last problem, I found the variable, but I wasn't asked for the variable. I was asked to find the side length of AB, and I know that AB is 4x minus 5. So if I take x is 15 and plug it in for x, then it's 4 times 15 minus 5. So that is 60 minus 5. So that is 55. All right. Number Number 23. Solve for x. Alright, this is one of those where you have to just start where you have a value, something you can work with. I see that there's 98 degrees and there's x. I can't really do much with the x, so I'm going to start with the 98 degrees. 98 degrees is right there. And I see this is an isosceles triangle. This side matches this side. And the angles that are across from those sides are also going to be congruent. Two like sides means two like angles. So I know that this angle is going to be the same as this angle. And if the vertex angle is 98, and all triangles have a total of 180 degrees. So if I started with 180, and I took away what I know, the 98, that's 82. So I have 82 degrees to split between the two base angles. So to split it in half, I'm going to divide by 2. And that's 41. So that means each of these is 41 degrees. All right, now that I know that that is 41, I'm trying to get from the left triangle over to the right triangle. So what is the relationship in the middle of this bow tie shape? They're vertical angles. And you always can tell because they have this bow tie shape or hourglass shape, the V's that share a vertex, however you like to think of that. We know that they're the same because vertical angles are congruent. So that means this one is 41 degrees. And now I see I'm in another isosceles triangle. This one's marked with 2 lines and this one's marked with 2 lines. So those base angles are also the same. So this has to be 41 degrees as well. Okay. So now there's 2 different ways I could solve for x. I could figure out what the vertex angle is, which really it's the same as this one, because if these are both 41 and these are both 41, then the third angle has to be the same. So 98 and 98. And then do 180 minus 98 to get to 82. And so x is 82 degrees. Or I could use the exterior angle sum theorem that tells me that if 41 plus 41 is 82. So the sum of the exterior angle is equal to the sum of its remote interior angles. So the sum of the 2 across. So either way, I find out that x is 82. X is 82 degrees. Alright, so then I'm looking at number 24. Similar type problem. I start with 119. That's all I have really to start with. And I'm trying to find out what x is. It's in the other triangle. So I see this is a straight line. And I know that a straight line is a straight angle. It's also 180 degrees for a straight line. So this is 180 because and this is a linear pair. A pair of angles that make a line. So I could do 180 minus 119, and it tells me what the other one is. So 61 degrees. Okay, so now I know that this angle is 61 degrees. So now I'm inside the triangle on the right. I can see it as isosceles, as this line and this line. So two of the angles are going to be the same, the two base angles. This one down here is not a base angle because the marked sides are the legs and the base is the other one. So the base angles have to be over here. So that means the other angle is also 61 degrees. So these are the same because these sides are marked the same. And now I can find the vertex angle by saying 180 and subtracting both of the base angles. Minus 61, minus 61. That's 58. So I know the third angle in that triangle has to be 58 degrees because all triangles add up to 180 degrees. And then I see something special right by that 58. The 58 and another angle make 90 degrees because there's that box right here in the corner. So if I want to find out what the other angle is, I could do 90 and subtract the 58. So that's 32. So I know this side is 32 degrees. So this is just a series of what do you know and what can you figure out next. One little step at a time, just working your way over. All right, so now I'm in the left triangle. And I see the two sides of the left triangle are the same as well. So that means the two base angles are the same. I don't know what they are, but I know they're equal. I know the whole triangle is 180 degrees. So if I do 180, subtract the 32, and then split it in half, that would be both of the base angles. So again, start with 180. This time I'm subtracting 32 because that is the one angle of that triangle that I know. So 148. And then I want to split it in half. So 74. 148 divided by 2 is 74. So that means that each one of these has to be 74 degrees. So x is 74 degrees. We had to figure out every angle in that picture to find that. Alright, so we have two more of those. You just work all of these the same way. Just start with what you know and work your way over. Okay, so if I have the 115 degrees. The only thing I can see to do with that is call this a linear pair. And I could do 180. So linear pair. Do 180 minus the given 115. Should be 65. So I found out its match is 65 degrees. And now I'm in an isosceles triangle because the two sides are marked the same, the two angles are the same. So that makes this 65 degrees. And this is a vertical angle. These are the hourglass or bow tie shape, so that is also 65 degrees. And now I'm in another isosceles triangle because these sides are marked the same. So the other base angle is also 65 degrees. So that one was not really all that bad. We only solved one thing. And then we just knew the relationships and just carried it over. So x is 65 degrees. So even though they look similar, like number 23 and number 25 look the same, well, pretty close to the same anyway. I solved them differently. I could have actually solved this one the same way. Oh no, the x is over here. So don't assume you're going to solve the problem just like this on the test because the picture kind of looks the same. You have to just see what you have and what you can do with it. All right, one more of these. We have to start with the 40 degrees. So 40 degrees is the angle at the vertex angle of an isosceles triangle. I know it's isosceles because the two sides are marked the same. So I can say that the base angles are going to be the same. So for this one, I'm going to say the triangle is 180 degrees. And I know that the vertex angle is 40. So now I have 140 degrees that I need to split between two angles. So there's 70. So each one of them is 70 degrees. Oh, I didn't even really need to do that, did I? That doesn't help me solve for x at all. It's true. That is true. It just doesn't help me get to x, does it? If I want to get to x, I'm kind of stuck. That's all I can do with that triangle. I skipped over this 90 degrees, right? So really, that didn't help me do anything. Down here, there's the 90 degrees. So 90 and then subtract the 40 on the right. Tells me that the other side is 50 degrees. That's what I was looking for. And now I'm in an isosceles triangle because the two sides are the same. So the two base angles are the same. So that means that x is 50. Alright, so that didn't help. It's not wrong, it just didn't help. Alright, so the last problem. Ray in P is an angle bisector. This isn't even this unit, this is previous unit stuff. Ray in P, because there's an arrow on it, is an angle bisector of angle M in Q. If the measure of P in Q is 5x minus 8, and the measure of M in Q is 4x plus 8, solve for the measure of M in Q. So when you just read a bunch of letters like that and numbers, it doesn't really make a lot of sense. So this really needs a picture. If I have an angle bisector and I don't see triangle anywhere in this, I'm just dealing with an angle. This is from a previous unit. So I have an angle, right? angle MNQ. So I'm going to put MNQ. The N has to be in the middle of the picture because the N is in the middle of the 3 letters. And then I have ray, NP, is the angle bisector. So from N, going straight out, is P. And I know it's not just splitting up the angle, but it's bisecting it. So I'm also drawing the angle, and I'm marking each side congruent because it's been bisected. So that is very important. Because it means they are the same. Okay, then it says if the measure of P and Q, so P and Q is 5x minus 8. P and Q, 5x minus 8. And then it tells me that the measure of M and Q is the entire thing. That is 4x plus 8. Solve for M and Q. Okay, so I have this piece and I have the whole thing, but I don't have this other piece on the left. What is the value of the piece on the left?
The same as the one on the right.
It is the same as the one on the right, the 5x minus 8, because it's been bisected. It's an angle bisector. So this is also 5x minus 8. So I could write this either using multiplication, saying 2 times 5x minus 8 equals 4x plus 8, or I could write it out as 5x minus 8 plus 5x minus 8 equals 4x plus 8. So the two parts add up to equal the whole thing. And then I can combine like terms. So x terms are like terms. I have 5x and plus 5x, so I have 10x. And what color have I not used yet? Orange. And I have a negative 8 and a negative 8. Negative 8 minus 8 is negative 16. And that equals 4x plus 8. All right, so now I have an equation that I can solve. So if I start with the solving, I want to get the x's together. So I'm going to subtract 4x. 6x minus 16 equals 8. And then add 16. So 24. So 6x equals 24. And then divide by 6. So x equals 4. Is that what it asked for? Did it ask for x? No. It says solve for the measure of M and Q. M and Q is what I did in pink. Okay, so this is M and Q is this. And I want to solve for the measure of M and Q. So that means I need to take that x equals 4 and plug it in for x of that piece. So 4, instead of x, I left a blank, plus 8, and that's where I put in the 4. And then solve it. 4 times 4 is 16. 16 plus 8 gives me 24. So this is the measure of angle MNQ equals 24. All right. That covers everything that's going to be on your test.